is very closely related to. So the notion of a trait is very closely related to the concept of a mix-in that I introduced. Does anyone remember where in this class earlier I introduced the notion of a mix-in? Find in quite a few languages, but it really dates back to CLOS, the Common List Object System, back in the 70s, I think it was, the latest, the 80s. And, well, we should be more careful with that. So, mix-ins. What did this have to do with? I introduced the topic. Well, it was in the context of subclassing. Okay? Subclassing. And the issue was that there are really two issues that I want to hit on, that I want to emphasize. One is, when we deal with subclassing, one consideration that we have to grapple with is the issue of single versus multiple inheritance. Okay? What do I mean by multiple inheritance? What do I mean by inheritance? I'm not talking about the inheritance that Donald Trump got from his father, Fred Trump, which he complains was, during his Fred Trump's life, merely $1 million, small $1 million loan. And complains about it. But no, I'm talking instead here about inheritance in a computational sense. And what do I mean by this? What do I mean by inheritance?
Subclassing versus having multiple parent classes.
Good. So generally, if we have one class, like Y, U, C, and D, okay, if we have a class A and it's a subclass of B, we'll say that A inherits B's mechanisms. And what that means is that it gets to reuse the implementation B provides. And then it can adjust it. It can override it. It can define a new version of some of the functions, for example, for itself. And Scala provides this. Some languages, not including Scala, not including Java, but notably including C++ and including Smalltalk, the sort of progenitor of these things, actually allow for multiple inheritance, B, C, D. Okay? They allow A to inherit from B, C, and D. Okay? And in that case, A will be getting elements of the implementation of B, C, and D. This is allowed in C++. Why is it allowed, or why do you think it's not allowed in Java? Why do you think it's not allowed in Scala? Why do you think it's broadly, many people view it's a mistake that it was allowed in C++? What's the problem?
The casting issue?
Okay.
Like if you were to cast A to be a C,
yes,
you would no longer know if it's valid type B.
Okay, yeah. So there is actually very good here. Eric, is it?
Yeah.
Yeah. Very good. So there actually is an issue with C++ that can lead to strange things when you try to take an actual value of type A and you try to render it into a C or a B. You can actually slice it in strange ways. You get back at like a partial piece of it, which is very strange and can cause real problems. So that is actually an issue. You're right. Actually, and it's a subtle issue, but it can mean bad bugs. And I remember being bitten by them and when I was wearing a younger man's shoes. So it's not a fun thing to work with. What's another problem with it? Well, let's suppose that this is some of you might like this. Suppose this is a graduate student, okay? Or it's a graduate student, okay? And And we have superclasses here. That's student and employee. Okay? So you get paid and you're a student at the same time. Now, suppose you have an ID as a student and an ID as an employee. And now you want to ask, what's your graduate student ID? It's not going to be clear which one of these I'm referring to. If I call ID on graduate student, do I want the student ID or do I want the employee ID? It's not so clear. What's more of a concern computationally yet is the fact that both of these might inherit from a person class. And now there's a question, okay, so a graduate student, do they have one person class that both of these inherit from, or does each of employee and student have a separate copy of person? It's not so clear. And so in languages like C++, you have this bending over backwards and contortions to deal with the fact that you'd like to sometimes keep only one, sometimes have multiple. There's this thing called a virtual base class, which allows you to capture these things, and it's really unpleasant. More to the point, it's dangerous, it turns out. It's dangerous in terms of when you have casting involved, okay? And it breaks sort of the normal layout of the objects. So you get this situation where, a graduate student is a subtype of, or a subclass of person, but through two separate routes. And it turns out that can cause, this is called the diamond problem, and it can cause big confusion. So one problem is the diamond problem, and how to deal with a base class that's, in other words, a superclass that you can get to via multiple routes. Do you make copies of it? Do you have only one version? So that's one thing that's wrong with it. And a second thing that's wrong with it, you might have same method defined multiple times. Defined multiple times in multiple superclasses. So defined in multiple superclasses. Okay, those are two big problems with that, and those are things I'd like for you to remember. Okay, with multiple inheritance. So multiple inheritance these days has been kind of banned from many languages because of these problems, and yet it offered some values to it, because you can inherit useful features from multiple things. And as a result, we have ways in Java of trying to get some of the benefits of multiple inheritance without this encumbrance of these problems that come from pure multiple inheritance. So we'll make use of certain types of abstract classes, for example. So in Java, we have some ways to try to let us mix in elements of multiple classes, but it's fairly weak stuff, honestly. It's not that powerful. So that's one motivation. It's this idea that we'd like to be able to take multiple lines of implementation and mix them into our given class without having this problem of the diamond problem and multiple types of inheritance, okay? So that's one issue. We'd like to be able to take multiple implementations and mix them into our class so we can reuse elements of implementation. That's one motivation. A second motivation is, in some cases, we'd like to separate subclassing, reuse of implementation, from subtyping, the ability to pass it around as if it's one of the, as if it's this other implementation we're reusing. Scala doesn't really deal with that, but it does deal with this issue of getting multiple types of functionality mixed in with your class. And it does it through traits, these things called traits, okay? So traits, in some ways, they replace interfaces in Scala. In fact, you can use any Java interface as if it were a trait. Okay, and here the idea is we can provide reuse from multiple sources of implementation without multiple inheritance. We can mix in sort of this bit of implementation, that bit of implementation, and traits can inherit from classes, from one class, but then you can mix in elements from other classes. And in fact, you can have a given class that draws on multiple traits that each have a common superclass, but it's not going to include that superclass along multiple lines of inheritance. We'll see some examples of this. Okay, so elements of traits, it turns out, are not inherited. They're kind of instructions for adding things into a type. Okay, and we're going to see that there's this very interesting syntax for calling things, which has a very different role than in classic inheritance. Okay, so the ways in which we're going to use traits are going to make heavy use of a syntax I'd like to explain. And it's really easy to get confused about it, just like we saw with match expressions and unapplied. Okay, so we're going to write things like this. Class my experiment extends simulation experiment with visualizer with run logger. Okay? Now, the thing that might strike you is you've got an extends, this is typically a class, and then you have with a trait. Okay? And it's easy to misread this. You think like, wait a minute, why do we have extends for simulation experiment, but we have with the traits? It's best not to read it that way. It's best to read it like this. Extends, and then everything after extends is together. Simulation experiment with visualizer with run logger. Those are traits being woven into whatever's in simulation experiment, and we're extending that. Okay? So instead of reading it like this, where it's class my experiment extends simulation experiment, and then next with visualizer, and then next with run logger, it's best to read it as my class experiment extends, and as one whole thing, simulation experiment with visualizer with run logger. Okay? So we can do this for a class, and it turns out that one of the real things that's interesting here is we can do it at an object level. We can actually say new simulation experiment, and at that time, ladies and gentlemen, we can tell it what traits we want it to run with. We could say, create a new version of this class with these traits, as we're allocating an object. Now that's quite different, right? You can't do this as you're allocating an object, say, hey, make a subclass of this other one. You have to do that in the class definition. But here, we can do it when we're allocating an object, okay? Okay, so let's talk about these traits that are being woven in, these things here like visualizer and run logger. Okay, okay. So here's a trait, and I'll go back to that last slide. So here's a trait, and this trait is going to allow us to do some logging, and it's going to have, this log method is going to be abstract. It needs to be filled in. Okay? It's not filled in now. It's abstract. And each of these calls are going to go to this logger here. So these are concrete methods. They are defined, but they are calling off to this abstract method. Okay? So we're going to have a logger, and when we mix in a logger, it is going to be mixing in implementation for all of these, but it will need this part to be filled in. It will need this part to be filled in by the thing that is using it, or by one of the other things that's being mixed in with it. Okay, so let's take a look at this. Here's a trait logger. This is a trait. This is inspired by Scala for the Impatient by Horstman, an example there. And I've taken some liberties at modifying some things to bring out some additional components. Okay, so now we have a savings account. This is a class, and it extends some accounts class with this trait logger. Okay,
and now we're going to have a withdraw, and it's going to call off, for example, to the severe here, to the severe log thing with some logging some message insufficient funds. Okay. So here we are calling off to a concrete method, but we're going to need log filled in. Why? Because logger has all these guys defined, but it doesn't define log. This still needs to be defined. So if we have the savings account, we need to for example, mix it in with something where log is defined. An example here would be console logger, which extends, this should be logger, and it does so with providing a specific definition of log. Okay, let me correct that because it'll be confusing. It extends logger with a particular definition of this. So then we can say new savings account with console logger. So let me ask this, just so we're clear. If I said new savings account, if I said this without these with, what would happen then? I know my head's blocking. What will happen then? What do you think the Java compiler will be happy? Why not? What's missing? Why can't it allocate a savings? You're correct. It cannot say new savings account. Why not? What's missing from it? It has no log. So let's trace this logic back. So if I said new savings account, let's consider savings account. Savings extends account with logger, okay? So it extends account, whatever's an account, with this logger trait. Now logger, in order for it to do its job, it needs a log message. Does savings account provide one here? No. So if we try to allocate a savings account, it'll say, where's log? I can't do my job without log. You need to provide a log. So how do we get that? We mix it in with console logger. And console logger provides the log. Yeah. It provides this missing log. So we're having some piece of it come from logger directly. You notice we're extending account with logger. And then some piece of it is coming from console logger. Namely, this log message here. This log of console logger is providing that missing piece. Alternatively, notice we're doing this while we're allocating the value. We could new savings account, and we could say with file logger. In a file logger, instead of just printlning it, it might put it out to some file. So that will provide a different implementation of log. Does that make sense? Okay. So ladies and gentlemen, here we've kind of mixed in some functionality here in logger, and then we've provided a console logger which provides some of this missing functionality, and we mix it in when we allocate actually an object. We can mix and match which type of specific logger do we want when we're allocating a new savings account. Okay? Okay. So ladies and gentlemen, this is an illustration of abstract method. This is abstract. In other words, we don't provide an implementation of it. We provide concrete implementations of these guys, but we only provide an abstract implementation here. We just say there needs to be a log of this form, a log method. And yet, these concrete methods are going to call off to log. Okay, they're going to call off here to log. And so we need to fill this out. Okay, so very frequently, we will have provide an implementation and a trait for certain methods, like these guys, but then they'll call off to some abstract method that needs to be filled in. And it needs to be filled in either by a subclass or a direct subclass or these other things which are mixed in here. Okay? Okay, so let's, I'm watching the time here. Okay, so here we're going to see that traits are using with, okay, so that you can mix in a trait with an existing superclass. So here we have extends account. This is the superclass of savings account. This is a trait that's mixed in with it. Okay, and you'll notice that all Java interfaces can serve as traits. We can treat them as a trait. But in Scala, we can have an implementation beyond what you have in a Java interface. So let's take a look at this, okay? So here we have a situation where we have a trait logged, and this one is different. This has an empty action here, okay? This isn't just no implementation. It's actually providing implementation. It's just not a particularly interesting one. Now, we might say, for example, savings account, we will mix in this, but then we'll have a console logger that extends this with some more meaningful one. And here we can mix in a savings account with this console logger. And ladies and gentlemen, what will go on here is if we call account.log, it'll actually be calling this one as the primary one. It's the last one mixed in. And hence, because the console logger is the last one mixed in, this will be printed out, okay? Rather than this earlier one, this logged. So it's true console logger did get this guy from extending it. Notice you can do with traits, but you can also do extends. And so it got this empty one, but then because we mixed this one in, we've kind of overridden it. We've now been doing this more meaningful one, this one that's not empty, but instead is printing things out. Okay, let's take a look at a somewhat more sophisticated example here. Here we're going to sort of mix these two cases. So here we have logger as before. These guys delegate to it. And this guy is calling off to severe. And then we're going to have console logger that extends logged, and it overrides this with this. Okay, so it's extending this logged here, but it's overriding it, and we can mix that in. Okay, so it overrides the log that is provided here in logged. Okay. Now, where it gets really interesting, ladies and gentlemen, is by layering of these things. So let's go take a look at this. So here, we're going to have logger, and this will have this empty implementation, and we're going to have info warn and severe as before. Okay. And then we're going to have a console logger, and in this case, ladies and gentlemen, it's going to print something out, but it's then going to call super. Now, in Java, when you call super on a method, you say super dot some method name. What happens? What is called? Anyone know? So if in an implementation of a method in Java, you call super with the same method, same method name, what's going to happen?
Call the superclass for it.
That's right. You call that method on your superclass, on a graduate student. Well, okay, if we had A as the subclass of B, and we called, and A had a method that called, say, super.foo, it would call foo in B, for example. Okay, if there was a foo defined there, or in a superclass of that. Okay, so ladies and gentlemen, here we're going to have a different notion of what super means. In a trait, this is a trait, console logger, this is instead going to delegate to any other loggers that are declared before it. Okay, so we're going to have something like this, ladies and gentlemen. Here, we're going to have a savings account, again, extends account with a logger, and then we're going to have an account, a savings account, which is going to mix in two types of loggers, console logger and file logger. Okay? And what's going to happen here, ladies and gentlemen, is that we're going to get successive chaining
where one of them will print something out and it will delegate to the next, and it will ultimately will delegate to logger where nothing will be done. So we're going to have this situation where each successive trait does something and then delegates to the next one. Okay, let's take a look at another example of this. Okay, so we might have, for example, a trait logger, and here this is actually abstract. Okay, and then we're going to have a console logger, and this is going to print something out directly, and then we're going to have these decorators. Okay, these are going to override. Okay, so this should actually say extends logger. These are going to override the log message. They're going to just pass on a call to the next one, passing on this information. Okay, so here we're going to have this log message, and it's going to pass on a what it will be printing out to the next one in turn. This is going to pass it on to the next one in turn. And here you'll notice that we're going to ultimately need something which prints these out. Right now these are just delegating. They're passing on a string to the next one in line. They're passing on a string to the next one in line. And so we're going to have ultimately here the need to fill in a specific logger, like a console logger, and extend it with these things so that each of these decorators will be calling, passing it on to the next, passing it on to the next, and will ultimately reach the console logger, which actually prints it out. So here, these guys are sort of delegating and ultimately reaches something like a console logger or a file logger that prints it out. Okay, so here we're going to have successive buildup of material to print out, and this will be responsible for printing it out. For example here, this one, the counting logger, might be numbering the lines. This one here, the timestamp logger, might be annotating them with a time. And each one of these in turn is putting more information on. Ultimately, it's going to be printed out by this console logger. Okay. Now, what's missing here, and what I really need to do is I need to make it clear that these are extends logger, and these guys need to extend logger as well. Okay. So here, what we have is a situation where we have several traits. These traits are mixing in capabilities to count lines, mixing in capabilities to timestamp lines, and mixing capabilities to output to the console. Those are being added to savings account here. They're being added to sort of supplement the behavior of savings account. Savings account here does not itself know how to log. The only way it knows how to log is because console logger and these successive other traits, these decorators, are being added in. They provide the log functionality. They provide the successive log functionality. However, the log and the decorators alone is not sufficient because they're delegating. They're just saying, okay, include this information and now pass on to the next trait to actually do the logging. And each one of them is going to include successive information, in this case line numbers, in this case date and times. But ultimately, it's up to console logger to provide the complete implementation at the base, which is just going to print out a message. So here we are having counting logger decorator. When you call log on it is going to successfully delegate to timestamp logging decorator, successfully delegate to console logger. So to be clear, when severe is called here from the savings account, what it will be doing is going through each of these in turn. The counting logger decorator will be called first. It will append some information, the line number. It will call the timestamp decorator. That will append some information, the date and time, and that will call the console logger, and that will actually print it out. Does that make sense? So, big picture, let's step back here. What do we have here? How is this different from our traditional situation? How it's different is, ladies and gentlemen, that we are getting the ability to bring in functionality to our implementation, our account, from many sources. Traditionally, we are restricted to have one superclass. We can reuse that implementation from there, but otherwise we have to provide our own implementations of things. We can implement many interfaces, but we have to provide the implementations of them, right? We can't inherit them. Right? That's a limitation in Java. We could say, I'm a class, and I extend this class, but I can't say I extend this and that, right? I can only do that once. Now, I could say I implement this interface, that one, that one, that one, but those are just promises I make, and then I have to actually fill them in. I have to actually write the methods to accomplish them. And so, while we'd like to bring in implementations, not just promises, but implementations from multiple classes, we can't say extends A, comma B, comma C, or else we end up in this diamond problem. And that leads to bad things, okay? Trust me. So what are we doing here that's different? Well, here, what we're doing is we're getting the ability to draw in implementation of things like logging messages from multiple sources. We're getting to bring in implementations from this counting logging decorator, from this timestamp logging decorator, from the console decorator. And we can mix them together with our class so that we can get out a mix of functionality that's implemented from multiple sources. It's almost as good as saying we extend this and this and this. We're getting multiple lines of kind of functionality out of it, of implementation of it. So that's one good thing we've got. Do you see that? Do you see that? Multiple implementations of logging, each doing different things we can reuse easily by bringing them in as traits. By saying with this. Not only that, ladies and gentlemen, we get extra freedom because we can do that when allocating an object. We could say, hey, this object implements this class with this trait to do file logging. This other one with this trait to do logging to the console. This other one to do logging via HTTP post to a server. Maybe this other instance of a class can do all of them. We can mix them together as we're allocating the object, not just defining the class. So we have this extra freedom to mix and match functionality as the code is running about what types of functionality we want for our objects here. Do we want to log via HTTP post? Do we want to log via file? Do we want to log to a database? Do we want to log to a console? Do we want all of them? We can mix and match as the code is running instead of just declaring a class, which can only do some subset of those. So we've gotten two things. We've gotten flexibility in terms of picking which we want to mix and match into our particular object, but we've also gotten the ability to tap into multiple lines of implementation, which is something we can't do with traditional Java single inheritance in an easy fashion. There are ways around it. You can use delegation. You can basically embed objects instead in Java, references to objects, and have wrapper classes and so on. But this provides a particularly nice way of doing this. It also provides a nice way in terms of chaining, of allowing those different pieces of functionality to work together nicely, to play together. One,
passes off to the next, passes off to the next, passes off to the next, in terms of calling its successive methods. So we can mix them together and they play nicely together. Does that make sense? Okay, a lot of detail here. I don't expect you to know all this detail. What I do expect you to know is those basics which I've just emphasized, that traits allow you to mix together multiple lines of implementation, that they allow those implementations to play together nicely, if you say via delegation, and they allow you to choose which you mix in for particular objects on a case-by-case basis with a lot of generality. Okay, and I provide more examples here, but I don't think we have time to go into these. Okay, lots of details, but those are the essential pieces I want you to know about. Traits, those features of traits. Okay. And don't worry about all the details here. You will not have to, in either a take-home exercise or an exam, be responsible for all these details. But just for those essential features of traits. They give many of the benefits of multiple inheritance without the handicaps, the encumbrances, the dangers, and the inflexibility of multiple inheritance. Okay? So thank you very much for your patience with this. As with most of the material in the class, it's a first time presenting it, and I'll have to refine this, but thanks very much. I'll be posting a take-home exercise for today, and I'll be sending out a message to the class once those things are pushed out to all machines and Spinks rather than just being on TuxWorld for Aspect J. Okay? Thank you.